look at evaluating a polynomial using the remainder theorem. So to kind of demonstrate this, what we want to look at is synthetic division. So firstly, if a polynomial f of x is divided by x minus k, then the remainder is the value f of k. So let's kind of look at this for a minute. So let's say we do synthetic division with this. So our coefficient is going to be 6, -1, -15, to -7. And we're going to be dividing by 2 since x equals 2. So we bring down our 6. 2 times 6 is 12. We add, we get 11. 2 times 11 is 22. We add, we get 7. 2 times 7 is 14. If we add this, we get 16. And 2 times 16 is 32. And our remainder would be 25. Now, let's say we wanted to evaluate f of x at 2. So that would be 6 times 2 to the 4th power minus 6 cubed minus 15 times 6 squared plus 2 times 6 minus 7. So in this instance here, you would get, if you plug this in, you would get 25. So basically what the remainder theorem is saying is, if you were to evaluate a function at a point corresponding to the root or the 0 of the polynomial, then you will get the remainder. So you don't even have to do the division. You can just evaluate if you need to find the remainder. Let's look at another example. So let's say we were asked to find the remainder of dividing f of x equals 2x to the 5th power minus 3x to the 4th power minus 9x cubed plus 8x squared plus 2. And you know, if we divided it, it would be x minus -3, or it would be x plus 3. But at any rate, let's say what's the remainder here. So I would do f of -3, which would be 2 times -3 to the 5th power minus 3 times -3 to the 4th power minus 9 times -3 cubed plus 8 times -3 squared plus 2. If you were to plug this in your calculator, you would see that the answer would be 26. And this would be your remainder. When you divide 2x to the 5th power minus 3x to the 4th power minus 9x cubed plus 8x squared plus 2 by x plus 3. And you can always check to see if this is the case. Okay. Now we're going to look at using the factor theorem to solve a polynomial equation. So here, according to the factor theorem, k is a 0 of f of x if and only if x minus k is a factor. So here we are asked to show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Now, after we determine that it's a factor, or we prove that, we have to find the remaining factors and use that to determine the zeros of the polynomial. So we have quite a bit going on here. So let's take it in pieces. First, we need to show that x plus 2 is in fact a factor. And to do that, we would do synthetic division. So we'll divide the 2. If we get a remainder of 0, then it is a factor. Okay. Negative 2 times 1 is negative 2. You add the 2, you get negative 8. Negative 2 times negative 8 is a 16. You add the 2, you get 15. And then negative 2 times 15 is negative 30. What do you notice? Oh, my remainder is 0. So that means x plus 2 is actually a factor of the polynomial. Next, what we're going to do is write our answer. So recall, when we write the answer, we go 1 degree less. So this will become x squared minus 8x plus 15. Okay. So basically what this means is if I multiply my answer by my divisor, I'll get the original equation, which was x cubed minus 6x squared minus x plus 30. So now they're asking us to find the remaining zeros. So here we have x squared minus 8x plus 15 times x plus 2. So if we're finding the zeros, we know that we have to set the equation equal to 0. We know this already corresponds to a root of x equals negative 2. So now we have to find the other factors of this quadratic expression. Recall, to factor, we have to find two numbers that multiplies to give us AC and adds to give us B. Here AC is 15 and B is negative 8. The only two numbers that come to mind are negative 3 and negative 5. So this becomes x minus 3, x minus 5. Note that we can do this if the coefficient of our x squared term is 1. So instead of having to split this like we would normally do, if the coefficient of your x squared term is 1, you can go straight to your parentheses. So, and if you were to split it, you'll see that you'll still get these answers. So with these two, we know that x minus 3 equals 0, x minus 5 equals 0. So that means x equals 2, x equals 5. So our three roots, or our three zeros, are negative 2, 2, and 5. Okay, let's look at one more example. Use the factor theorem to find the zeros of the given polynomial. And they're telling us, they said, oh, given that this is a factor of the polynomial. So again, we would do synthetic division. And remember, you take the opposite sign here. So this becomes 2 times 2 is 4. We add 2 times 4 is 8. Actually, 2 times 8 is 16. I must be going crazy. This is a 1. 2 times 1 is 2. This becomes a 6. 2 times 6 is 12. Then this will give me 8. 2 times 8 is 16. So we see that the remainder is 0. So that means my solution becomes x squared plus 6x plus 8. And this times x minus 2 should be equal to 0. So again, we need to find two numbers that multiplies to give us 8, but adds to give us 6. And so 2 times 4 is 8. So I will say x plus 2, x plus 4. And again, notice that the coefficient for your x squared term here, a is 1, so you can go straight into your parentheses. And then this becomes x minus 2. So my solutions are -2, -4, and 2.